I would like to talk with you about full metal power, the metal-to-metal power sections without an elastomer, which are of interest, of course, for the hot geothermal drilling in energy and oil and gas, specifically in the geothermal, of course, for the hot temperature and under harsh conditions. And then specifically, you can also think about drilling with nitrogen and oil-based muds, but specifically the high temperatures are of interest. I would like to run you through a few things. So yeah, we know all what is ongoing with the thin walled or the even walled series, where you have a thin layer of rubber, which are a large improvement, of course, to the conventional ones. But we're also dealing with the holy grail, which is actually eliminating the rubber and then also eliminating the possible failures. And of course, there's a lot of improvement on the rubbers, but at the end, you still have limitations on the temperature or drilling with nitrogen and the oil-based muds. But yeah, also the holy grail, which is I think there for 20-30 years, is to make the metal-to-metal happen. Is how do you create a power section metal-to-metal so accurate that you will be able to maintain a small gap and still maintain a performance. We have been able to create a process like that. We call that electrochemical machining. It's based on electrolysis, and by means of electricity and chemistry, we're able to dissolve this accurate profile inside of the stator. Just some quick company introduction. At the bottom here you see three companies called ECM Technologies, Easy Profile, and Full Metal Power. ECM Technologies is the company that we started back in 2003, and ECM stands for the electrochemical machining technology. Continuing the company and fully focusing on a more dedicated product, we have set up the company Easy Profile as electrochemical profile, where we are building stators with the technology of electrochemical machining. And since the beginning of last year, we have introduced the full metal power, where we are really focusing on metal-to-metal power sections. So, like I mentioned, we already have a longer history, specifically based on the electrochemical machining, which all started back when I finished my study in 1969, where we are working on the electrochemical machining for the shaver heads of the Philly shave, which is known in the US as the Norelco shaver. So the slots, the holes, the polishing, the leveling, 100 million components are machined annually by electrochemical machining. And in 1999, we developed that technology for the production of the turbine blades for the Joint Strike Fighter. In 2003, I thought, okay, this is a cool technology. So I started the company ECM Technology as a consultancy. Then the first introduction, because within that time period, we worked for a lot of different kind of industries, for the aerospace, automotive, medical industry. But first introduction into oil and gas was back in 2009, where we looked into the possibility of profiling the stator for an even wall application. In 2013, we built the first demonstration machine. 2017, we found the company Easy Profile. Built a larger production machine, so we're now able to handle up to, let's say, 12 inches in diameter, up to 25 feet in length. Build a second line, 2020, the introduction of full metal power, and in 2021 we will continue releasing different more models from 11116 up to 958, hopefully by the end of the year. We have a facility in Leeuwarden. Leeuwarden is a small city in the north of the Netherlands in Europe, the neighbor country of Germany. And in that facility, we're now building up these production lines. These are lines up to 25 meters in length, and each line can handle the machining of those stators. And the idea is to build up something like 8 to 9 lines within the next 3 to 4 years, only profiling stators and rotors for the metal-to-metal power sections and even walled versions. So a small view on what is the technology and where does it come from. These two gentlemen, I think the left one you might know because that's René Monod, the inventor of the Monod principle. So the helical structure that we have now with the PCP and the PDMs. He started the company for pumps back in France in 1930, so roughly 100 years ago. Michael Faraday, you might not know, he's the founder of the case of Faraday, but also the father of the modern ECM technology. And he's also responsible for electrolysis, but also our battery systems. So we use his background. Also, everybody uses it. But that's back in 1834 when he published the Faraday law. So that's 200 years ago. And now, let's say 100 and 200 years later, we combine these both technology of these both gentlemen to the holy grail, what we call the metal-to-metal power section. We have built now several products, but the focus is on motors, power sections for motors and pumps. So these include the metal-to-metal, but also the even-walled versions that we are producing. Besides producing motors, we have also the ability to work on pumps. So we have 2 projects where we are working on developing the stator technology for metal-to-metal pumps. And other options are cracking calls for downstream applications, so where you're profiling large tubes which can be up to 14 meters in length for ethylene cracking furnaces. And then, of course, there are a number of other applications. Just a small insight of how the technology works. Based on electrolysis, we have a pre-drilled tube. We have a front runner that guides through it very accurately, and this is an electrode, and this electrode dissolves all the metal. So it's not a mechanical machining technology, but it's all based on electrolysis. So by means of electricity and chemistry, we have a small gap here in between, and the electrode erodes or electrochemically dissolves all the metal. And this long shaft here behind conducts a few thousand amps, and at a speed of a few millimeters up to 4 millimeters a minute, we're dissolving this profile very accurately over the length of the stator. And the same can be applied for the rotor. So manufacturing the rotor and the stator with the same technology in the same shop makes it feasible to combine that to a very good performing power section. This is an example of a small 278 where you can see a rather thin gap here between the rotor and the stator. So we have the rotor and the stator here combined, and by maintaining this small gap, this rotor just rotates on gravity and stays on the lower end. And by maintaining this small gap over the full length of a couple of meters, makes it feasible to get some very good, decent power out of a metal-to-metal power section. So what we are doing is we're designing the power sections here in-house, and by designing it, we need this electrode, like you saw in the animation. This designing process of the tooling takes 2 weeks, and then manufacturing of the tooling is another 6 to 8 weeks. So within roughly 2.5 months, we're able to present a new design to the market. And what we're providing is we're not a motor developer or a motor supplier. We're in the field of providing power sections, and everybody has its own proprietary technology on bearing packs, bottom ends, top ends. So what we have decided is that we provide rotor stator machined according to our electrochemical machining process, just as a blank. So we're providing blanks without threading, and in that way you're able to add your own threading and have your own bearing packs used. So the take-home message is full metal power, easy profile, full focus on ECM, and ECM. That's where our strength is. And that way we're able to manufacture the best possible metal-to-metal power section. Both rotor and stator will be surface treated in-house to guarantee and optimize longevity, and we try to produce those both in the same facility, and that's what we do for now from the Netherlands, and build up and extend the fleet with the different models over the period in this upcoming year. So for now we have the 278 in production. The 218 will be upcoming this month. We're starting this within 1 to 2 weeks. We have a 5-inch model on the market. It's a low speed version, so we're also working on a higher speed, which will be available by the end of the first half year. The 7-inch has been designed, the tooling has been ordered, so we're expecting that one as well by May, June. And then we have an 8-inch and a 958 on the roll for the second half of 2021. And that's in a nutshell the electrochemical machining and profiling technology of full metal power. Thanks.
Thank you, Hans. Very, very informative. I mean, to be honest with you, as a moderator for this section, I mean, I have a lot of questions. I mean, this is definitely I would call it a game changer. Nevertheless, if you don't mind, I will start with a question.
Yeah, go ahead.
Okay. So I do see that. Do you get first question? Do you make complete motor or just the power sections?
We from the Netherlands we make the power sections, so that's where our strength is, and that's also where our knowledge is. But we cooperate with partners in the field. So some clients require a power section and they can handle it themselves. But we also have several that just want a motor because that's the standard in the industry, and then we have our partners that we cooperate with, and then we run it by them.
Okay. So given the I saw that you guys making the through tubing application, obviously in nitrogen and the temperature and the geothermal wells, and I do see the application with the when pumping acid for the cleaning out paraffins and all the for the clean outs for the through tubing applications. But when it comes to drilling or even milling something out, do you see any well, first of all, if you pump acid through it, is there any kind of chemical reaction with a metal? That's the first question. And number two, do you see any of the vibrations given the metal to metal power section?
No, two good questions. I think that there is a learning curve we have to make with acids and with H2S, of course. We have a good chemical resistance, but the chemistry and the attack from acid and H2S can be very aggressive. The nice thing about the ECM is if you take a metal, we now use pretty well standard materials which are used in the industry. But if we want to move to very chemical resistant metals like the Hastelloys, the Inconels, which of course have technically other restrictions, but the electrochemical machining process is not limited to the hardness or toughness of the material. So where you would have conventionally limitations because of that hardness, we're depending on the chemical composition and just dissolve the metal. To give you an idea, Inconel could be dissolved faster with the same setting than, for instance, aluminum.
Mm-hmm. Right.
So I mean, that gives a good option there. And your second question again was
the vibration.
Oh yeah, the
vibration. Yeah.
No, we had yesterday. We had a 5-inch on the dyno in Houston, and the guy that was testing it was saying, normal with an elastomer, you see really the vibration. But because of this small gap we're looking at, it was running very, very smooth. And that's a benefit. But of course, that's also a further development we have to look into. But you can compare it like if you have some space within a bearing pack, a normal bearing, it starts shaking, and due to the shaking, it damages the surface. And we're trying to maintain a gap in the other magnitude of 1 to 2 hair thicknesses in that kind of order. So 3, 4, 5 thou, and maintain that over the full length of a couple of meters.
Okay. And as far as the torque output, I mean, do you see, obviously, do you have any specs on the torque output? In fact, the guy that was doing the testing, I was supposed to meet with him. That's a guy in Dallas that represents you. Is that correct?
Yeah, correct. Yeah. So to give you an idea, the a 278 power section of roughly 2 meters in length runs over a 2,000 Newton meter. And the 958, for instance, we have designed right now is anticipated to have something like 30,000 feet LPS. Yeah.
Well, thank you very much for answering my questions. Obviously, we have few questions from Q&A session. Scott Powell asking if is there a repair option to recoat rotor and stator as it wears?
Good question. Yeah, so when you normally have the elastomer, you replace the elastomer. For us, we have of course the stator and the rotor. Business-wise, for us, it makes sense to have the stator wearing. Because if we make the rotor wearing, then all our clients will start producing their own rotors. So business-wise, for our company, it's that we have the stator wearing, because in that way we can control. So the hardness of the surface are in the order of magnitude of 1200 HP, and having one sacrifice with respect to the other makes that the repair principle is more or less just replace it, because it's pretty tough to repair it and then maintain that small gap of a few hairs of thickness.
Thank you. And I would like to apologize to Ron French. He had asked the first question. Do you have any information on how solids affect the power sections, or the brine will affect it? So
no, that's a good question. So brine is not an issue. Actually, brine is the basic material how we machine it. So no, salt levels is not a thing. But solids is a question mark that we have to deal with. The forgiveness you have with elastomer is, of course, a big advantage. We don't have an elastomer. We have a very tight gap, and that tight gap has its restrictions. But we had one power section just running cement through it, so that's very abrasive. And of course, at the end, you can measure somewhere, but it can handle it. But large particles, that's a small gap. That's a restriction.
Right.
But we will do an extensive research on that in the future. Sorry.
Well, I was just going to tell Farhad, there's a couple of questions in the chat. Do you see the chat?
Oh no, I didn't see the. Let me see here. All right, yeah. So people asking, I think it's Gozi asking, do you have a rough performance specs for the 5-inch power section? And,
yes.
Okay, I guess maybe is it published on the website that they can go and check it out, or you can send it in the chat?
No, not yet, but send me an email and I'll forward it.
Okay, sounds good. And then the next question is from Tim. You mentioned in-house surface treatment to prevent it. It goes very well with the ECM treated surface. I guess is it a question, or is it a comment? I guess.
No, I think what Tim mentions. Tim is pretty well familiar with the electrochemical machining process. So combining a surface treatment with an ECM surface. So an ECM surface is rather smooth, as you might be able to see. It's more or less shiny. It runs on a couple of millimeters per minute through the surface, and the adhesion or the treatment of an surface treatment process runs very well with an ECM surface. So Tim, thanks for that.
Well, thank you very much. It was very informative. Obviously,
actually, there's one more, Farhad.
Okay.
I think you passed on this one intentionally, because it's Siva Kumar Mathanagopalan asked the question. You just didn't want to take a shot at the name.
No. I'll go short if it's okay. Siv.
Okay.
Siva, extremely interesting metal-to-metal technology. Are these speeds? How do you avoid something like friction welding, let alone performance?
Avoid friction welding.
He's essentially saying that the metals don't bind themselves to each other.
Okay. Yeah. No, of course, the surface treatment itself, but running the metal to metal in, of course, an environment with the drilling liquids in between, of course, prevent friction welding, and it's not rubbing continuously on the same spot. It's scraping all over. And what we have done with our latest design, that it's rolling over instead of scraping over the surface. So the contact mechanism is also different than you would have with friction welding. But I like the way of the question. Yes.
Sounds good. All right. Well, very, very informative. We have come far since Jim was talking about how decade ago or 2 decades ago or 3 decades ago things were different. I mean, we have definitely come far with even wall, even rubber thickness, power sections, and here we are. So thank you very much to all the presenters, and I'll turn over to Jim to highlight anything or move to another section. Thank you, gentlemen. I appreciate it.
All right. Thanks, Farhad. Thanks, Hans.